All right, this is problem step 42, number 16. Finding the greatest common factor and then factoring it out. They give us 4x squared m to the 5th y minus 2x to the 4th m cubed y cubed. Remember, we're looking for the greatest common factor here, the largest thing that we can divide out of all of those terms. When we have something like this where each term contains a numerical part, coefficient, and also some literal parts, they're called, or algebraic parts with the variables, we can treat each one separately. So we can look first at the numerical parts. What's the greatest common factor with the variables? We can treat each one separately. So we can look first at the numerical parts. What's the greatest common factor of 4 and 2? 2. What's the greatest common factor of x squared and x to the 4th? X squared. What's the greatest common factor of m to the 5th and m cubed? What's the greatest common factor of y and y cubed? Y. All right. Then when we divide that out of the first term, what are we going to get?
2m squared.
2m squared. The x squared we've already divided out. The y we divide out. And then the second term minus what?
X squared.
Yeah, I just don't understand why you're doing the second part.
Okay, in the second part, so first I find the greatest common factor. This is the largest thing that can be evenly divided out of each of these. Yes? That's what the greatest common factor is? Okay. Then what I'm doing is I'm then actually, in fact, going and dividing it out of each of those. So first we do the first term divided by the greatest common factor. 4x squared m to the 5th y divided by the greatest common factor.
Oh, if you're like subtracting it from that one.
Well, I'm not subtracting, I'm dividing it. I'm taking this and dividing by this. So 4 divided by 2 gives me 2. X squared divided by x squared gives me x to the 0. So I can ignore that. M to the 5th divided by m cubed gives me m squared. Y divided by y gives me 1, which I can ignore. Now in the second term, I'm going to leave my subtraction there. 2 divided by 2 gives me 1. X to the 4th divided by x squared gives me x squared. M cubed divided by m cubed gives me m to the 0. And y cubed divided by y gives me y squared. Once I get to that point, if I did this correctly, this is the opposite of the distributive property. At this point, I should be able to check my work by then going and multiplying each term by this, and I should end up with the original thing. So if I multiply these two together, I'm going to get 4x squared m to the 5th y minus, and multiply these two, 2x to the 4th m cubed y cubed. I did this correctly, and I can tell because I ended up with the same thing. This is the distributive property in reverse. When you're finding the greatest common factor and factoring it out, you're doing the distributive property in reverse. So first find out what we're going to be dividing out, then we divide it out of each term that's there. And write it like one of these distribution things. These two are equal to each other. It's just two different ways to write the same thing, but depending on our problem, one may be more convenient than the other. So we need to be able to move between them.
That's one y squared. The last part.
Yes. Yep.
So you only divide by the greatest one.
Right. We're just dividing by the greatest common factor.
I mean, the biggest factor that you didn't put inside the first equation. So like, since there are number 17,
Mhm.
it's like 3. You only divide it by the biggest one. So like,
We divide each one by that same greatest common factor. You find the greatest common factor of all three of those terms in 17. And then we divide each one of them by it. However many factors we have, however many terms we have, whether it's 2, 3, 4, 5, whatever, once we find the greatest common factor, we divide that out of each of them. Just like if we have the distributive property, we could have something like this. Whatever. However many are in here, we're going to multiply them all by that. Here we're doing the opposite, we're dividing it out. Other questions about 16? Have a volunteer go ask very nicely in the front office for a new dry erase marker for me. Thank you very much.
Could do number 2.
Number 2. Yes, the sum of twice the number of negative 3 is multiplied by 4. The answer is 28. Find the number. All right, so if what?
If the sum of twice the number in 3 is multiplied by 4, the answer is 28.
Okay, so what things there can we translate into mathematical symbols?
Sum of twice the number,
The sum of,
twice the number and negative 3.
okay, so what does that mean? The sum of twice the number of negative 3.
2n plus negative 3.
Yeah, 2n plus negative 3. That's the sum of twice the number. 2n is twice the number, and negative 3 is the sum.
Multiplied by 4.
So what gets multiplied by 4?
24n plus negative 3. 2n plus negative 3 times 4.
Parentheses.
Why do I need to use parentheses? You're correct. I do. But why? Sum, thank you. The sum of them is being multiplied by 3.
Oh, that's
So
where I messed
first,
up.
they need to be added together, and then we multiply by 4. And then the answer is 28, right? Yeah, so this is why. When they say the sum, note it's not negative 3 that's getting multiplied by 4. It's not twice the number that gets multiplied by 4. It's the sum that gets multiplied by 4. And if we don't put the parentheses there, then following our order of operations, we'll do the multiplication first and then the addition. But that's not what the problem says. The problem says to take the sum, to first do the addition, and then multiply that by 4.
Well, you can't do this.
Yeah, I did this before.
What do you mean you can't do the sum?
Wait,
Oh, you did it.
I'm so stupid. I know I got it wrong.
This is the sum. We're multiplying it by 4.
So you don't use the distributive property.
Right. So what are we going to get?
4 times 2n equals 8n. And then 4 times negative 3 equals negative 4.
Yep.
So you can carry over the 12 by adding 12 to both sides. Then you get 8n equals 30,
40.
40.
That's why I messed up. I put 30.
N equals
5.
5. Yep. There you go.
I didn't use the distributive property, that's how I moved up.
So yeah, be careful when they say things. Anytime there's an operation in one of these problems where you're translating from words to math symbols, make sure you ask yourself, what is this operation being performed on? So when they say the sum of twice the number of negative 3, the sum, there's some addition going on. What things is it happening to? It's happening to twice the number and negative 3. All right, that part's pretty straightforward. But then when we say is multiplied by 4, read that sentence. The sum of twice the number and negative 3 is multiplied by 4. It's not twice the number that gets multiplied by 4. It's not negative 3. It's the sum of those two that gets multiplied by 4. So that when we write it out and translate it into symbols, we need to make sure that the way we write it here is telling us to first take the sum and then multiply by 4. And that's why we need to write with the parentheses. Because otherwise, the order of operations, we do multiplication before addition. The parentheses are just a way for us to make things happen in different orders than they normally would in the order of operations. All right, next.
Yay.
Any others from this problem set?
That's the only one I had trouble with.
How did 25, 26, 27, 28 go?
What are the answers? Oh, wait, I think I got.
What answers you have?
25 is 18, 26 is negative 2, 27 is negative 11, 28 is 5 over 9, 29 was 40 plus 20 pi meters, and 30 is 2,000 pi square inches, cubic inches.
God.
I have a question for my last problem set.
Yep,
What answer to number 30?
number 30 in 41. 41, number 30 is 56 pi square centimeters.
Got 27.
Number 27? Okay, let's do 27. 27, 1 over -3 to the -2 minus cube root of 8.
Oh.
All right?
So I'm gonna take that one right there, and you're gonna flip it around, and then it's gonna be.
Which one right where?
That one right there.
Fraction.
That'd be 1
There.
minus 9.
The fraction, so why are we going to flip it?
Because to make exponent positive.
Yeah, we don't like negative exponents. They're not the worst thing. They're not as bad as decimals.
Yeah.
But
Yeah. Get out of here.
but we still don't like them. So yeah, we can move this to the top. And so what will it become instead? Instead of 1 over -3 to the -2, what will we get?
What?
9 over 1.
No.
It'll be -3 over 2.
What?
9.
Yeah, -3 squared. Thank you. Okay. Minus cube root of 8. Okay, let's just change one thing at a time. Now, okay, so now we've simplified it. Now let's apply our order of operations. Order of operations tells us to do what first?
Exponent.
Right, there aren't any parentheses, so we do exponents. So what do we do? What exponents do we have to deal with?
We have to,
Negative 3
Negative
squared.
9.
you get
Thank you. What does this give you?
negative 9.
Negative. Why negative? Why not positive 9?
Because you don't want this, so you multiply the negative afterwards.
Cover the
So you
negative sign, do the exponents.
Right, the exponent comes first. First we square 3, then we do the multiplication that makes it negative. So it gives us -9. And what's the cube root of 8?
2.
Yes. In terms of order of operations, remember that your roots
Oh.
count as exponents. No, the cube root, not 8 cubed, but the cube root of 8. We mean what number will get us 8 if we multiply 3 copies of it together.
Oh. Oh my god. I put 24 in the
It's a good idea to be familiar with the first couple powers of your smaller numbers. So like 2, what?
Oh no, I saw something.
Like 2 squared is what? What's 2 squared?
4.
Is 4. 2 to the third is?
12.
2 to the fourth is?
16,
2 to the fifth is?
32,
32. 2 to the sixth is?
64,
Okay, those are
54, 56.
That way you can break that down.
remember it's 3 times 3 times 3 times 3. We multiply them together in any order. It's 81 because it's 9 times 9. Okay? 3 to the fourth is 81. With 4 squared is 16. 4 to the fourth, 4 cubed is?
32.
No.
Wait,
That one.
Take this and multiply it by 4.
That one.
54. 54.
64, yes. What's 5 squared?
25.
25. 5 cubed?
125.
125. It's good to be familiar with these.
No.
You don't have to have them memorized necessarily. Just put the other class's book away. You don't even take that class. Put it away. Anyway, it's good to be familiar with these, just so you recognize them, because these are the kind of numbers that they'll often ask you to take the roots of.
Oh, I found it. Here we go. Yeah.
All right. Any others from problem set 42 that you want to go over?
Nope.
You guys figured out 29? Where the perimeter there are 2 straight sides, and then the other 2 sides are these semicircles?
Even.
Sure.
Okay, wait, so,
One equivalent class without Mr. O yelling. 'cause
Kilogram is about 2.2 pounds. Say again?
I think we went to class without you yelling because Ashley was not here.
No.
Am
Yeah.
I-
There's no action.
Do I yell?
Please, can we
I don't think myself as yelling so much as being loud.
Get a dress code.
Yeah, the dress code thing.
Yeah.
All right, so we've got this heart-shaped thing for Valentine's Day. We've got 2020.
My man Isaiah going.
They shouldn't even need to tell us that. Listen. They shouldn't even need to tell us that the radii of these. Did you listen? That the radii of these semicircles are is 10. We should be able to already figure out that it's 10 because all the way across is 20, right? Okay, we're looking for the perimeter. So the perimeter, we need to do what? To find the perimeter of something weirdly shaped.
For this.
You that one plus that one plus that one.
What is the perimeter?
The perimeter is all the outside numbers.
Is the measurement around. We want to walk around the outside. So what do we have? We've got this and then, okay, so if we start here,
You put that one.
okay, we're gonna go around here, that's easy, that's 20 meters. Then we're gonna go around this corner,
And then you get that one.
it's another 20 meters. Now the question is, what about these two round parts? How do we find the length of those?
You do that.
What?
You do that one.
What?
You do that one. 10.
You do that one.
Yeah, it's 10.
Okay, what is this 10 here?
It's 10. The number is 10.
Rating.
Yeah, but what is it? Yeah, that's the radius.
No, I'm
This
saying
is,
like the whole thing is 10.
no, it's not.
Oh, okay.
Are you?
It's not. The rate, notice, 10 is the inside, is that radius there. That's not what we're walking along. We're gonna walk along this, on the outside.
Yeah.
That is definitely not 10. We know it can't be 10 because, look, from here to here is 20, right? Straight across. But we're going the long way around, so it's gotta be larger than 20, whatever it is. Okay, now, how do I find that distance, that curve?
10 plus 20.
Okay, now you're just making things up. What kind of a shape is that?
It's like a
Semicircle.
It's a semicircle. Okay, so how do I find the length of the curved side of a semicircle? Pi times diameter will give us what? Pi times diameter gives us the perimeter of what? Of the whole circle. Here it's a semicircle. Oh, but how many of them do we have? We've got 2 of them. So it's like we're walking around the whole outside of the circle, yes? Because we've got 2 identical semicircles
Yeah.
where the radius is 10, but there's 2 of them. Yes?
Yes.
Yes, there's one here, and there's one here. So how do I find this measurement around the circle? What's the formula?
Diameter times
Right, circumference equals pi times diameter. What's the diameter?
20.
Yes, how'd you get that?
10 times 2.
Because the radius is 10. So 20 pi is that. So we've got 20 meters here, 20 meters here, and these two together are 20 pi. Or you could say each of them separately is 10 pi.
That's what I said.
So it's 40 plus 20 pi meters. Any others?
No.
You guys found that volume correctly? How do you find the volume of a right solid in general? What's the general formula for volume? Is what? That'll work if it's a rectangular prism. But if it's some other shape, we're not going to necessarily have a length and a width to multiply by the height.
2 times area.
That's surface area.
I think it just.
Volume, this is a formula you need to know. Because this is a cylinder.
You multiply by the height.
Yeah, area of the base times the height. For a right solid, which includes cubes, it includes rectangular prisms, triangular prisms, cylinders. These are all right solids. Any right solid, use this formula. Area of the base times the height. It doesn't matter what shape the base is. Just find the area of the base and multiply by the height, and that'll give you the volume.
So it's 100 pi times 20.
Yes, because inches. Remember, since it's volume, you're always going to have cubic units. You got to know this formula. You got to know the surface area formula.
Like, if it's 10 times 22. Wait. Oh, no, never mind.
Anything else?
No.
Going once. Going twice. All right, go to page 171. Let's talk more about lesson 43 with least common multiples. Please do not get least common multiples and greatest common factors mixed up. They both include the word common, but that's about it.
Do we have one more?
Probably, yeah. 43. Let's try that. We talked yesterday. So what's the difference between the greatest common factor and a least common multiple? What's the greatest common factor? We've been working with those for a lot longer.
Between all the numbers.
Let's be a little more specific.
A number that can be multiplied by the greatest out of the number can be multiplied by.
That's what I said. The greatest
I don't know how to put it in
number.
words, that's the thing.
The greatest number
Like, I know
between
it's
two
mental, but I
algebraic.
don't know how to
The
put it in
greatest
words.
number that can be divided out into two algebraic expressions.
Or more, 2 or more.
Yeah.
Yeah, the greatest common factor is the largest thing that can be divided out of any one of a number of algebraic expressions. It's the biggest thing. But it's always going to be no larger than the smallest of your terms, right? So if we have, you know, 4, 10, and 20, if we're looking for the greatest common factor of those, we can't have something that's larger than 4. Because it's always got to be something that we can multiply up to each of the terms there. So at most it could be 4. It's got to be something that's less than or equal to 4, so your smallest term.
You bad boy. It's away. It's your book. It's your book. It says it's your chemistry. It's your book. It's
That's
your
the only
algebra.
calculator out of both.
It's your algebra 1 book. You can't even. It's fine. See, I have the notes. Well, some notes. Past lesson, bad boy. From probably.
The least common multiple, on the other hand, is a multiple. This is the smallest thing that we can multiply all the numbers up to. So like that example at the beginning of this lesson, if we're looking at 4, 5, and 8, okay, we're going to be multiplying each one up. We've got 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, okay, 5, 10, 15, 20, 25, 30, 35, 40, and then what's the last one? 8. 8, 16, 24, 32, 40. Look, in terms of multiples of these numbers, this is the smallest one that they share in common. Okay, this is the least common multiple. They have other common multiples like 80. You can yes, we talked about this yesterday. I'm reviewing here.
Oh.
They also have 80 as a common multiple. But we want things that are going to be more convenient for our use. So let's use the least common multiple, the smallest one they share in common.
So the number 5 just had to go to root. It would have been 16.
But you have like a.
No, it would have been 8. It would have been 8 otherwise. The least common multiple of 4 and 8 is 8. Because 8 times 1 gives us 8.
Uh-oh.
And 4 times 2 gives us 8.
Okay. Well, what about 8 times 0?
0.
No, it means at least 1. It's got to be at least 1. We're multiplying up or staying the same. Now, how did we say yesterday, how do we find the least common multiple of larger numbers? What if we have 30, 75, and 80? Least common multiple
That you factor it out.
of 30, 75, and 80. Yes. So 30 is what? How do we rewrite 30?
10 and 3.
No.
15 and 15.
No.
15 and 2.
52, my bad. Yeah.
No.
Man, I have no idea. I'm so confused.
Break it all the way down. 30 is what? We do 3 times 10 and then?
That's what I said.
5 times 2.
Yeah, so 30 equals
3 times 2 times 5.
2 times 3 times 5. Okay, what about 75?
Oh, got me there.
75 is what?
5 and something.
You should recognize 75 because 3/4 is 75
It's
cents.
14.
What?
No.
Alright, 14 or 15.
Okay, let's say 75 is 3 and 25. Yes?
Yeah, it is. Oh.
Yes. Okay, 3 is prime. 25 is
5 and 5.
5 times 5. So 75 is what?
2. Oh.
3 and 5
2
squared.
times 3.
No, there's no 3 there.
3.
75 is 3 times
Oh, I was looking at the other one.
5 squared. Yes. And what about 80? 80.
40 and 2.
Okay, 40 and 2.
20 and 2.
20 and 2.
10 and 2.
10 and 2.
5 and 2.
5 and 2. Okay, so 80 is what?
2 to the 4 times 5.
2 to the 4th times 5. Okay, once we have them all broken down into products of prime factors,
Then you add up exponents.
then, right, so our least common multiple,
Anyone have extra?
we don't need 2 to the 5th.
What do you mean?
It doesn't need to be 2 to the 5th. Why? Can't we, why do we need 2 to the 5th? It's easy to multiply 2 up to 2 to the 4th.
It is.
Yeah, you just multiply it by 2 cubed. Right?
Yeah.
Okay, 2 is 2. 2 to the 4th is 16. It's easy to multiply 2 up to 16.
Okay. Okay.
multiply by 8. You don't need, you only need 2 to the 4th. The exponent only needs to be as large as the largest exponent on any one of your numbers.
So that's just 3.
And then 3, right, we only need 3 because we only have 3 to the first.
And 5 squared.
And 5 squared, yes. 2 to the 4th times 3 times 5. If we wanted to, we could say 16 times 15, or what would that be?
It would be a
16 times 15, anyone?
16 times 2.
Or you could say 48 times 5.
That's going to be 48 times 5. That's
240.
240, yes.
Yeah, 240. There's your least common multiple. You can write this though. Oops, this.
Yeah,
Hey, you don't need to multiply it out. You can write it as a product of prime factors. That's if we're dealing with just straight up integers.
big number.
We're finding the least common multiple.
So
Now-
if we're above 10, then we just do that.
If you can't easily do it in your head, yeah, do this.
Okay.
You know, if it's like 5 and 10, okay, it's 10.
Yeah.
Like it's 5 times 2 is 10. But, you know, or if it's like 2, 3, and 6, it's 12. No, sorry, it's 6. I meant 2, 3, and 4. 2, 3, and 4, it's 12.
2, 3, and 4. Oh, yeah.
Right. But if you can't just do it in your head, do this. This will always work. Notice you can also use this method to find the greatest common factor.
Okay.
Right? So once we break them down into their prime factors, not only can we use this to find the least common multiple, we can also use it to find the greatest common factor, which is the largest thing that they all share in common. What's the largest thing that all 3 of these share in common? Do they share 2 in common?
Yeah. No.
Why do I have one student participating and everybody else looking down? Do they share 2 in common?
No.
Okay, so it's not 2. Do they share 3 in common?
No.
Do they share 5 in common?
Yeah.
How many copies of 5 do they all share in common?
1.
Yeah, so it's 5. The greatest common factor of these 3 is 5. Notice how this trick of breaking things down into their prime factors is really useful for finding least common multiples and greatest common factors.
Yeah.
Don't you think that's amazingly helpful and useful?
Of course.
Yeah.
Yes, Mr. Oriani, thank you so much for teaching us this. I don't know how I would have survived Algebra 1 without you. I know. Thank you so much. I'm very modest. Okay, now.
Wait. Wouldn't you not be able to survive without a
Actually, no.
What?
I did
Wouldn't we be able to survive Algebra 1 without a brain?
Okay, now, how does this work? What if we want to find the least common multiple of some things that aren't integers? What if we want to find the least common multiple of, for example, 15a squared b and 10ab cubed?
Well, then that's when we burn our books.
No. All that we need to do is break these down into products of factors. So, 15a squared b, how can we rewrite that?
You could write it as
3 and
3 times 5 times what?
5.
a times a.
Yeah, times a squared times b. What about 10ab cubed? What can we write that as?
Oh, okay.
2 times 5 times
A
times-
B.
times b cubed.
Oh, so you would do 2 times 5 times A2 times B3?
So you do 2, right? We need 2 and 3 and 5. So each one of these things has to be represented. And we've got a in there, but how many copies of a do we need?
Squared.
Right, because we've got 2 copies in that one. It's easy to multiply a up to a squared.
And then B cubed.
And then b cubed. There's your, and you can simplify this. 2 times 3 times 5 is what?
That's 3. Oh, that's what I was gonna say.
Okay, there's your least,
Whoa.
there's your least common multiple. It's the same process.
No, that's wrong.
B cubed.
actually.
You can also find,
5A
oh sorry,
B.
Yeah. Sounds good.
5AB.
5AB, yes, 5AB. Because they share 1 copy of 5 in common, they also share 1 copy of A and 1 copy of B. We can use this same process to find the least common multiple and greatest common factor. All right, let's do another one. and then I'll let you guys get to work. So we've got
The rest of the period, be on a phone, do whatever you want.
no.
He means do something productive.
We want the least common multiple. Let's do the greatest common factor also. 12 x squared am squared and 14 x cubed am to the fourth.
Yeah,
So let's write these as products of prime factors. So the first one, 12 x squared am squared. How can we rewrite that?
3 times 2 squared
Yeah, 2 squared times 3 times what?
times x squared am squared.
Times x squared times a times m squared. 14 x cubed am to the fourth, we can rewrite as what?
7 times 2 times x cubed times a times m to the fourth.
Yes. Okay, so the least common multiple is what? Remember, the least common multiple needs to have every single one of these terms represented.
2 squared times 7 times x cubed
Well, we skipped one. 2 squared times
3
3.
times 7 times x cubed times a times m to the fourth.
Okay, and what will that give us? Again, I still have one student participating, everybody else looking down.
Whoa, I think we should
I haven't even handed out the sheets yet. So what's the least common multiple going to be? 2 squared times 3 times 7?
That can be a big number.
Well, what's 2 squared?
4.
What's 3 times 7?
21.
21 times 4 is? 20 times 4?
80, 84.
84, yeah, 84 what?
84 x cubed a m to the fourth.
Yes, there's your least common multiple. And what's the greatest common factor while we're at it?
X.
Start at the beginning.
Oh, 2
2,
x a m
2x, 2.
x squared
Mm-hmm.
a m squared.
Yep, 2x squared am squared. All right? Yes?
Yeah.
Some sense? Now,
Yeah.
make sure you pay attention to what the problem is asking for.
Okay.
But you can use this method to find greatest common factors and least common
No
multiples.
problem.
Yay, go algebra.
Yeah.
For tonight, please do problem set 43, numbers. Oh, you get to skip 3 this time. So 43, except,
Hold up. What? Wait. No.
yes.
Capital. We have space tomorrow.
What?
That's what I saw, bro.
Who's a quiz tomorrow?
So I just forgot.
In scripture?
Again,
Didn't we just take one yesterday?
yes.
Well, I forgot
Sure.
I erased it.
You lying.
Huh?
See, I just forgot I erased it.
Okay, problem set 43, except numbers 3.
Yeah, it's about like Solomon.